Let's talk about rational exponents. So rational means it's a fraction, exponent in the exponent position. So basically rational exponents are the exponent way to write radicals. So a to the m over n is well, let's apply the rules of exponents. That's a to the m times 1 over n, which is a to the m to the 1 over n power. The 1 over n power, a to the 1 over n, is nth root of a. So applying that, then we have nth root of a to the m. That can also be thought of, though, as the other way around, as nth root of a to the m power. Just by switching the order of the multiplication. It's a to the 1 over n to the m. M over n, for this to work, has to be a fully reduced fraction for the rules to apply. So you wouldn't have like a to the sixth root of a to the fourth, whatever. You fully reduce. If a is negative and n is even, so you're taking an even root of a negative number, can't do it. Then that does not exist. But otherwise, so yeah, just generally a to the 1 over n is nth root of a to the 1/2 then is square root of a. If you think about this, so let's just visualize, let's just think base 2. So 2 to the 0 power is 1. 2 to the 1 power is 2. 2 squared is 4. Now, what's square root of 4? 2. So if I want this to be base 4, we have 4 to the 1. 4 to the 0 is 1. And then we have halfway between there, 4 to the 1/2 is 2. So you can kind of see that fitting with the idea of half. Similarly, so 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3rd power is 8. 2 to the 4th power is 16. This gives a little more to work with. So you can see then 16 to the 1, 16 to the 1/2 at 4, 16 to the 0 at 1. So you see again the square root of 16 being halfway between, on this powers of 2 number line, halfway between 16 to the 0 and 16 to the 1. 8, so we have 8 to the 1 is 8, 8 to the 0 is 0. Well, then 2 would have to be 8 to the 1/3. 4 would be 8 to the 2/3. Well, cube root of 8 is 2. And then we have that fraction 2/3. That would be cube root of 8 squared, or the square of cube root of 8. And either way, that does come out 4. So that's just to kind of visually see how this fits, of these being fractions of the powers, for the powers. All right, so 4 to the 1/2 is square root of 4, that's 2. Negative 27 to the 1/3, that's cube root of negative 27, which is negative 3. 4 to the 3/2 is 4 cubed, square root of 4 cubed, or the cube of square root of 4. And it's generally going to be easier actually to evaluate the square root first and then apply the power. 2 cubed is 8. So we see that here on this line. So 4, we had 4 to the 0, 4 to the 1/2 is 2, 4 to the 1 is 4, 4 to the 1/2 or 3/2 is 8. Right, negative 8 to the 4/3. Just looking at positive 8, we had 8 to the 0 was 1. 8 to the 1/3 was 2, 8 to the 2/3, 4, 8 to the 1 or 3/3, 8, 8 to the 4/3 then would be 16. But how does that work with applying this rule? So -8, this would be cube root of -8 to the 4th power. Cube root of -8 is -2. Take that to the 4th power, and it actually comes out positive 16. All right, going the other direction, rewriting each radical expression as an exponential expression. Square root is 1/2 power, so square root of x plus 1 is x plus 1 to the 1/2 power. Cube root of e to the 7th, well, that is e to the 7th to the 1/3 power, which is e to the 7 times 1/3, or e to the 7/3. So if you have trouble remembering the direct rule, just do it one piece at a time. Cube root is 1/3 power. What does it mean to take e to the 7th to the 1/3 power? Well, that means you multiply the powers, and when you multiply 7 times 1/3, you get 7/3. All right, so that's rational exponents.